Hello student, welcome to the first video lecture of FDS Subject, Fundamentals of Data Structure. I am Pujashri Vedab and I am taking this subject for your class. So before starting with the actual Unit 1 content, I want to give the introduction to this particular course or the subject. So before starting with the Unit 1, we will see the overview of this subject along with the course objectives and the outcome. As you know, every subject we will have the 6 unit. In this subject also we have the total 6 unit. So the first unit is Introduction to the Algorithm and Data Structures. So in the first year FPL subject, we have seen that for solving any problem, we have to think the problem solving process. In that, we have to write the instructions step by step. We have to store the data in some data structure, maybe variables and maybe array, and we have to write the algorithm to solve that particular problem. So this algorithm is nothing but what the stepwise instruction that we will carry to solve the problem. So the first unit will give you the introduction to the algorithm. What are the different tools for writing the algorithm? Along with that, we will see that for one problem you have the different algorithm. So we have to analyze the algorithm. Which algorithm is better? Which algorithm is average performance wise? Which algorithm is worst performance wise? And we have to see the introduction to the data structure in this unit 1. The unit 2 is based on in the unit 2 we have to start with what the actual data structures. So in this particular subject we will only deal with what the linear data structure. So the unit 2 is going to deal with the linear data structure such as array, 2D array, and we will see that how the polynomial or the sparse matrix we will represent by using this data structure. Therefore, the unit 2 is linear data structure using sequential organization. The unit 3 deal with different operations or different methods of searching and sorting. So we will see what are the different searching and sorting technique along with what the performance analysis of the each sorting and searching technique. The fourth unit is deal with what the non-linear data structure but the dynamic memory allocation. So we will see the singly linked list, doubly linked list along with what the generalized linked list GLL. The fifth unit is based on the data structure called as a stack, that is what the last in first out, and this particular data structure we will along with this data structure all the operation we will also see what are the different applications where we will use this particular data structure. So the sixth unit is queue. So in the queue again we will see the how we will implement this particular data structure. We will see the performance analysis of the each operation along with the application where we can use the queue. In this way, the syllabus is divided into the 6 unit. All the 6 unit are going to deal with only the linear data structure such as arrays and the linked list, stack and the queues. Along with that, we are going to deal with what the various searching and the sorting technique. So before starting with the unit 1, first see what are the different course objective of this course. So the first objective is to understand the basic techniques of the algorithm analysis. So as we know, for any problem there we can write the different algorithms. So we have to see what are the different techniques are there to analyze that algorithms so that we can select the best algorithm for the performance wise. Second objective is to understand the various algorithmic strategies to approach the problem solution. So there are the different strategies or the approaches to solve the problem like divide and conquer, dynamic programming, greedy approach. So we are going to see all these algorithmic strategies and how we can apply that to the problem to solve that problem efficiently. The third objective is to understand the memory requirement for various data structure. So we will see that how the data structure require the memory. So for stack, what the memory requirement is there. For array, how the memory requirement is there. So we will understand the memory requirement for various data structure. The fourth objective is to understand the various data searching and the sorting methods with advantages and the disadvantages. So we will see the different techniques along with the analysis, detailed analysis, so we can understand that what is exactly the complexity of the searching and the sorting algorithm. So the next objective is to acquaint with the structural constraint and advantages in usage of the data. So we will understand how the structural constraints of the data structures are there so that we can apply or we can use that data structure in the particular problem. Next is to understand the standard and abstract data representation method. And next objective is to identify the appropriate data structure and the algorithm design method for a specific application. So if I will give one problem, so you have to identify the data structure which you will use to manage or store the data. Along with that, how to implement or how to write the algorithm for that specified problem. So these are the course objective. So next are the course outcomes. So these are the outcomes or the things that the student are going to achieve after completing the whole course. So the first outcome is to demonstrate the detailed understanding of the behavior of the data structures like array, linked list, tag and queue by developing the program. So here we are not going to only understand how they are going to represent in the memory, as well as we will also see that how we can write a program to demonstrate this particular data structure. The next course outcome is to use appropriate algorithmic strategy for better efficiency. So we will apply the particular algorithmic approach to solve the problem for the better efficiency. Next is to summarize the data searching and sorting techniques. That is the next outcome that we are going to achieve. So the next outcome is to discriminate the usage of the various structures in approaching the problem solution. So we will understand or we will differentiate the memory constraint and its usage of the different data structure. The next one is to analyze and use effective and efficient data structure in solving various computer engineering domain problem. So here for any problem we will identify the which data structures that we are going to use after analysis, and we will also write the efficient algorithm for solving that problem using that particular data structure. So the next outcome is to design the algorithm to solve the programming problem. So we will see the different tools for writing the algorithm, and we will see that how we can write or design the algorithm for the particular problem. So the evaluation scheme here, the 3 credits are given to this subject. In semester theory examination is consist of 70 marks. In sem theory examination is consist of the 30 marks. Along the practical subject, that is the DSL, is associated with this theory. So the DSL we have to perform some of the programs in the Python and some of the programs in the C++. So we have the external practical examination for the DSL of the 50 marks, and the term work is of the 25 marks, and the credits are the 2. So these are the some books that we have to refer for this subject. So the first two I mentioned that are the textbooks, that is Fundamental Data Structure in the C++ by Sahani, and the second one is Data Structure and Algorithms in Python by Wiley Publication. Along with that, you can use the reference book. The first one is what the Brazard, that is for the algorithmic fundamentals of the algorithmic for fundamentals of algorithms. So if you want to deal with more about the algorithms, we can use the Brazard. So the next books are depends on what the If you want to learn the algorithm with the C++ or the Python, so depending on that we can use the any reference book that is mentioned to deal more detail about what the data structure and the algorithms.